In this challenge, we want to see if the average wait time is the same across all three of our offices. Using the file patient data, we set up an alternate hypothesis that at least one of these offices will have different average wait times than the other, and the null will be that all offices have the same average wait time. Let's get started. Do our answers match? We will know in just a moment. We're going to focus on wait time, which is column G, and also break that out by office and compare those. Again, this is a stacked column format. So to do our Anova analysis, we go to Statistical Tools, One-Way Anova and Means Matrix, Entire Table Next, choose Stacked Column Format, Wait Time is the Y variable, and Office is the X variable. When we punch OK, the first thing we want to look at is going to be the p-value. Here you can see that the p-value is above 0.05. That is indicating that it could not find any statistically significant differences in average wait times by office. Therefore, we fail to reject the null hypothesis. This is not saying that the average wait times are the same between each office. It's saying that they could be the same between each office. The pairwise probability table is the same that you saw in the demonstration, where it's going to compare pairs of each of our offices. You'll notice that none of these p-values are red. All of the p-values are above 0.05, indicating that it did not find any pairwise differences. Before we scroll down and look at the confidence interval graph, we expect to see some amount of overlap between those confidence intervals. Let's scroll down and see if that's true. Here you can see that we could take our fork and jab it through all three of these pancakes, if you will. That means that there is no statistically significant difference between those. Our overall conclusion: fail to reject the null hypothesis, and we go back and state that we could not find any statistically significant differences in wait times between offices. Hopefully our answers match. Let's move on.